aggregate apparatus 2386 part 1. Apparatus are used. This is our elongation apparatus, elongation gauge. This is set of sieve. This is balance machine. This is our sample, and this is scoop and enamel tray. This is our set of sieve. It consists 20 mm sieve. This is 16 mm sieve. This is 12.5 mm sieve. This is 10 mm sieve, and the last one is 6.3 mm sieve, and this is our pan, and the top of this is lid. This is our sample. We place this. We will shift the aggregate up to 5 to 10 minutes. This is our 20 mm sieve. This is 100% passing the aggregate. This is 16 mm sieve passing through 20 mm sieve and written on 16 mm sieve. This is our sample passing through 16 mm sieve and written on 12.5 mm sieve. This is passing through 12.5 mm sieve and written on 10 mm sieve. This is passing through 10 mm sieve and written on 6.3 mm sieve. Now I will take 200 pieces of sample. And it will pass 20 to 16 mm gauge. This is not passed. written on 12.5 mm sheet. This is passing through 12.5 mm sheet and written on 10 mm sheet. It will pass. This is passing through 10 mm sieve and written on 6.3 mm sieve. There are two fractions. This is passing and this is written. We will measure written forces. We repeat this test and measure the weight. See the apparatus once again carefully. There are total 8 vertical rods resting on the wooden plate. 1, 2, 3, 4, 5, 6, 7, 8. Okay. First 2 rods we can see here. Upper gauge is 50 mm and lower gauge is 40 mm. The distance between 2 rods is specified a certain range of length gauge. The distance between 2 rods is specified by certain range of length gauge. First 2 rod we can see here. Upper gauge is 50 mm and lower gauge is 40 mm. The distance between 2 rods can be measured with help of a formula. Formula is 1.8 into mean dimension of length gauge. So 50 and 40. 50 plus 40 by 2, 1 point into 1.8 into 45, 81 millimeter length. Similarly, we can calculate the distance between 2 rods, 40 mm and 31.5 mm to 25 mm and 20 mm. The same process will be followed. Similarly, we can measure distance between these 2 rods. 40 mm and lower range is 31.5 mm. According to IS code 2386 part 1, the distance will be 1.8 into 40 plus 31.5 by 2. and it is calculate, and this distance will be decreases when we move starting to the end. Distance will be decreases. You can see here. Now comes to the calculation portion. Now we see the table. This is our table. We started 20 mm aggregate of sample in this test. So we'll use starting from 20 mm sieve to 6.3 mm sieve. We have taken in our experiment for the different gauge range. In 20 mm to 60 mm range, we found the weight 2.065 kg. 16 mm to 12.5 mm, we found 1.44 kg. 12.5 mm to 10.0 mm is 0.537 kg. 10 mm to 6.3 mm sieve is weight we found 0.226 kg. Now the total weight is 4.268 kg. So calculate this part. Weight of aggregate retained. 20 mm to 16 mm sieve retained. The retained aggregate weight is 0.362. 16 to 12.5 mm is 0.111 kg. 12.5 to 10 mm we found 0.066 kg retained sample. This is retained aggregate. 10 to 6.3 mm we found 0.026 kg. So it is calculate. So calculate the total weight. Total weight is 0.565 kg. So elongation index is equal to x4 plus x5 plus x6 plus x7 by w4 plus w5 plus w6 plus w7 into 100 percentage. This is the total weight 0.565 by 4.268 into 100%. We can calculate this. 0.565 by 4.268 to 100. 13.23%. So elongation index we can found 13.23%. Elongation index of coarse aggregate should not be more than 0.565 should not be more than 15%. So the elongation index should be 15. So elongation index should be less than 15% for pavement either bituminous or non-bituminous. Elongation index should not be more than 30% for non-wearing non-wearing surface like building, foundation, etc. So elongation index not be more than 30% for non-wearing surface. So this is our reading 13.23%, which is less than 15%. So we can use this aggregate in wiring or non-wiring surface. So this is the end of our experiment. So thank you everyone.